Everyone, welcome back to SAT Math Question of the Day. Here's the question. Please read it, pause the video, try yourself, and we'll offer hopefully different approaches on how to do it. Specific gravity is a ratio of decimal, that doesn't have to be a decimal, of the density of a substance to density of water. Density is the ratio of mass to volume. The mass of 700 gallons of fuel is 2325 kilograms. So why don't we just write, oops, I didn't do annotate, okay. 2325 kilograms per gallon. Okay, so at least we have that. Density has this funny symbol. Okay, it's a Greek thing. A single gallon of water has a mass of 3.8 kilograms. 1 gallon is equal to 3.8 kilograms. Okay, to the nearest tenth, what is the specific gravity of jet fuel? Aha, ratio problem, right? Specifically, I have to read what this is. What's the definition of specific gravity? The density of fuel divided by the density of water, right? This symbol here means density. Density of fuel divided by density of water. They gave us the density of the fuel, which I'll write neatly, 25 kilograms per 760 gallons divided by the density of water. Density of water is 3.8 kilograms divided by 1 gallon. And we have to erase some stuff. Excuse me. So that should do it, right?
Yeah.
That should do it. So that's the answer. So whatever this is the answer.
Yeah.
That's it. So it's just straight following your nose, as Seth would say, following your nose, using unit analysis to help you. The units really help you keep yourself honest. This is kilograms.
Yeah.
And that's it. That's the answer. So then we just use a calculator
Okay.
to get the answer, right?
Oh, right. Well, my approach, I would suggest, not writing as much.
Okay.
And then writing this formula and this case of the formula right away.
Right. You mean as opposed to writing the silly stuff that I was putting in? Yeah.
Yes.
Yeah. You're probably right. Right.
So again, the question is, what is the specific gravity?
Right.
What is specific gravity? Specific gravity is this. And now you fill in the information. Density of the fuel is given by these numbers. And the density of water is given by these numbers.
Yeah.
But again, one of the approaches, sometimes it's, one might, when reading the problem, pick in some problems a different approach. But one good choice among choices for approaches is start with the question they are asking.
Right. So what I wrote here is I wrote Joel's mistake. Read the whole question before writing anything down because it's a time test and you don't want to waste yourself. You don't want to have to waste your time writing something down when you don't really have had to have done that.
So what we do is read the whole question.
Right. Yeah.
And then and identify. No, read the whole problem.
Right.
That's then right. Identify what is the question.
Yes. Right. That's right. And then start writing stuff down. Right. That would have been better. Okay. So the last thing you do is you take the calculator out and you do 23. This is definitely a calculator question. 23, 20. Now, in terms of computation, you have to make sure you do the computation right. So it's 2325 divided by 760, and you take all of that, and then you divide by 3.8. Okay? So in a calculator, you do 2325 divided by 760, you get an answer, and then you immediately hit the divided by 3.8, and you get 0.8. Now there's a rounding thing, so we have to pay attention. The calculator says 0.8051. 0.80505. Okay, now to the nearest tenth. So to the nearest tenth is to the nearest dime. So it's 0.81.
Yeah.
And if you had extra time, you should double check your calculations.
No, wait a minute. Wait. It's to the nearest tenth.
Oh, you're right. That's to the nearest hundredth. Oh my God. Yeah. Oh my goodness. Oh my God. Oh, I wasn't thinking. Oh, I was talking, not thinking. So the nearest tenth is to the nearest dime. It's just 0.8. Thank you, Seth.
Yeah.
Oh God. See, that's the problem with talking while doing the problem. Anyone, you just try doing it. Like giving an oral presentation, you always make stupid mistakes. To the nearest tenth, right? Yeah. Okay. I hope everyone is comfortable actually doing the calculation that's specified here. It's a complex fraction. It's one of those fractions where it's a fraction divided by a fraction.
Mm.
So that's the thing to go over. This is the case where you have a over b divided by c over d, but this is the big divided by. That's a over b times d over c. See that? So this is 3225 divided by 560, all divided by 3.8 divided by 1. So you have to flip the 3.8 and the 1, and you multiply the top equation by the reciprocal of this, which essentially comes out to dividing this quotient by 3.8. Okay, everyone? So that you have to know how to do that. And then you have to not make a mistake in rounding. I even said to myself when we're doing it, better not make a mistake in rounding. Got to be careful about that. And of course, I made a mistake in rounding.
Well, a rule. No.
I'll bring it back.
No, it's okay. I could write a rule that's I find helpful, very helpful. Is I'll write it myself. A divided by B divided by C divided by D.
Yeah.
Okay, here we go. The B is in the denominator, and the A is in the numerator.
Yep.
Right? And the C stays in the denominator.
Right.
And then the D is double divided. And then so the rule says that D goes up here.
You want to see something? I've seen it taught this way, which is really interesting. A over B divided by C over D. What you do is you multiply top and bottom by the common denominator, BD.
Okay. Well, no. The point is, no. I think what you're doing is proving this rule.
Yeah, but
you're explaining why this rule is true.
Yes.
Well, what I'm saying is it's a good idea, after you understand or work through the proof, why it's true,
right,
to have it in your toolbox as a rule that you could apply quickly without taking the extra time to wonder if it's true.
Okay, I mean, I'm just saying that I've seen people actually do it this way in practice, and the teacher has taught it that way.
Yeah. I see. That's taught in practice, but I'm saying.
This is the University of Albany emergency notification system.
Oh, something's going on in Albany. What's happening? What's the emergency?
We could.
Uh-oh.
We'll talk about it later. They can cut it out.
Okay. Got it. Okay. Maybe we won't. Life has an emergencies in it. Okay. Anyway, And anyway, yes, you're right. I mean, Seth and I, we basically grew up doing it this way, but there, I've definitely seen it where actually people actually do it this way, which is a little slower, so it's not advised. But I don't know. Okay. So anyway,
Again, uh in studying for the SAT, if you have been taught to do it this way, it's a good idea. Following what we're teaching you is to learn a different way of doing it, which is this way,
you may not
which is
maybe
more,
a little
which is
faster.
more efficient.
Right, 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 right. Yeah, yeah, yeah. And you definitely should be familiar with the complex fraction. And yes, it just to be second nature. A over b divided by c over d is a over b times the reciprocal of c over d. Yeah,
Yeah,
yeah, yeah.
yeah.
Okay, okay. So I guess the answer was 0.8. Let's go for it. 0.8. That is to the nearest tenth. 8/10. Let's see. Okay, good.
They agree with us.
We agree. Yes, we both agreed. Let's get the entire answer down, and then we'll see how they did it. Did they start with the definition of the density?
No.
Yeah.
They started with the definition.
Gravity.
They did it the opposite way that I suggest.
Right. They should have started with specific gravity. Sort of like what I did after I wasted my time writing some stuff. You start with specific gravity, which is down here.
Yeah.
They didn't use formulas. They just put the stuff in. That's not good. It's better to do a little bit of writing, the answer, the specific gravity is density of fuel divided by density of water. It's nice to have that, and then you just substitute.
Yeah.
And they also
we're
also doing calculations
in engineering and science in college. They teach when doing a calculation, it's a good idea to generate the expression without doing any calculations first. Then at the end,
so true.
Combine all the numbers in one calculation step.
This is irresponsible. Completely irresponsible to show it this way. Of course,
that's right. Yeah.
Plus, you have these intermediate things, and if you're not careful, you can make a rounding mistake. Here, I mean, it's so irresponsible. Plus, the other reason why you want to show everything is because it's easy for your eyes to check the work. If you have this, it's hard to see what you're doing. You want the numbers to speak to you when you want the final expression to speak to you, so you can say, "Hey, I think I did it right." At least they put the units in, though. That's nice.
Yeah.
So anyway, that's right. It's one of our big points. And then of course they did it to the nearest tenth, which is good as opposed to what I did. So if you did 0.81, you would have gotten the wrong answer. Yeah. Actually, if you did 0.80, I wonder whether you would have been marked wrong. If you answered 0.80, you may have been marked wrong. I don't know. Too bad we didn't do that to play with it, but we can't go back. So, and they have show calculator. So on the digital SAT, you get a calculator, except you get a better calculator. I think you get a Desmos graphing calculator. So anyway, who are we? What are we doing? This is Seth Chaiken. He's a PhD in math from MIT. He's a professor emeritus at SUNY Albany, teaching computer science for over 30 years. I'm Seth's brother, Joel. I have a PhD in mechanical engineering, and we're here to offer different approaches on how to do the SAT math questions and also how to approach studying for the math SAT, which we suggest going to Khan Academy, taking one of their courses, either the digital course or the non-digital course, to practice the SAT questions. Of course, you want to practice on real practice SAT tests given by the College Board, and that's another excellent way to approach studying for the SAT, although that one's pretty obvious. You want to take practice tests as many as you can. So please like us, dislike us, give us comments on our YouTube videos, and if you have any SAT math questions, you can send them to us at satmathquestionoftheday@gmail.com, and Seth and I will try to do them. Okay, that's it for today, right?
Right.
And
Goodbye.
tomorrow is Throwback Thursday, when we go back 20 years. Well, we do a question from the modern test, and then we also go back and do a test from about 20 years ago to contrast how the SAT has changed over the last number of years. Okay, everyone. Have a great day, everyone. Bye-bye. Bye-bye.